Hello my dear students, once again welcome to your online class. Hope you had a very good Dasera holidays and now it's time for you to come back to your virtual classes again. So in this video we will be discussing about the 6th chapter of your physics textbook and the chapter's name is the transfer of heat. In this chapter basically we will be dealing with the 3 different kind of processes by which the heat is transferred from one object to another. So you must be already knowing that the 3 processes are the conduction, convection and the radiation. And finally we will also learn about the thermos flask, and the thermos flask is a device which helps us to keep a hotter liquid hot for a longer period of time and the colder liquid cold for a longer period of time. So now to begin this topic, the transfer of heat, we know that whenever the 2 objects, the object A and B, are at a different temperature or which contains the different amount of heat. Suppose the A is at 100 degrees centigrade and the B is at just 30 degrees centigrade. So what happens? So the heat flows from the hotter body to the colder body. Or you can also, like whenever you touch hot utensils, what happens? You feel warmth in your hand. That means the heat is getting transferred from that hotter utensils to your hand. So always the heat always flows when the 2 bodies are in contact with one another. But this transfer of heat, it can take place in 3 ways. In case of solid, it takes by the process of conduction. In case of liquid or gas, the transfer of heat occurs by the process known as a convection. And in space or in the absence of any medium, the heat transfers by the process of radiation. So we will be discussing about each of them briefly in this chapter. So talking about the first process, that is the conduction. So the conduction occurs when the 2 bodies are in physical contact. They are in mutual contact with one another, just like placing your hand on a hot object. So that means you must touch that hotter object. So in that process what happens is, like if you have a fire, and in a fire if you put an iron rod and the other end you hold it with a hand. So here you have your hand. So what happens, slowly you will feel that the other end which you have held with your hand also, it also starts getting hotter. It is because the heat from the end A is getting transferred to end B. Now how does this happen? It happens because we know that this iron rod contains many molecules, or atoms. So what happens, the first atom, it gains some heat, and then after gaining heat it does not go to the end B, but instead it starts vibrating. When it starts vibrating, it touches its neighbor molecule, and when this second molecule starts vibrating, it will touch the third one. When the third vibrates, it touches the fourth one. So in this, the energy is transferred from particle to particle. So that is the process of conduction. So you will define the conduction is the process of transfer of heat in which the heat is transferred from a particle to particle. So that is known as conduction. Now also in this topic conduction, it's very essential to know the good conductor and the bad conductors. So what is a good conductor? The good conductors are the one which allows the heat to pass through them, and the bad conductors which are also known as insulators. So the insulators are those objects or those materials which does not allow the heat to pass through them. So the good conductor and the bad conductor, you must know the basic difference between these two. The good conductor allows the heat to pass through them, but whereas the bad conductor, it does not allow the heat to pass through them. So depending upon whether a given material is a good conductor or a bad conductor, there are many applications of the good conductor and the bad conductors in our daily life, like the cooking utensils. Mostly all the metals, they are good conductor of electricity and yes, electricity as well as heat also. So that's why all the cooking utensils, they are made out of the good conductor of heat, so that the heat easily passes through that utensils and the food is cooked faster. And if you see the same thing, like if you see some kind of pan, so usually the handles, they are made out of wood or made out of plastic, because wood or plastic, they are the poor conductor, so that when you hold it, you do not feel that heat. So there are such many applications of poor conductor and the good conductors. So the good conductors, they are usually used in such places where the transfer of heat or where the heat transfer is required to happen rapidly, and the poor conductors are used in those cases where you do not want to feel the heat. Okay, so those are the applications of the good conductors and the bad conductors. There are many others which you may learn from your book as well. Now coming to the second process of transfer of heat, that is convection. Convection usually occurs in the liquid and in the gases. So in this what happens is, you must have seen, okay, a tea being cooked in a pan or a sauce, okay, in any kind of vessel. Okay, so when you pour a water and then when you pour the tea leaves, okay, what happens, you will see that the tea leaves moves in a circular pattern. Okay, so it goes down, again comes up, again goes down, again goes up. Okay, so this is known as, actually that is the process of convection. So in the process of convection what happens, like, so in water, okay, so we know that the water, it also consists of molecules. So when it is heated, okay, the molecules at the basement, what happens, they acquire heat. Okay, they gain heat energy. On gaining heat, it expands and its density also becomes lesser. So after gaining heat, it ascends upward. Okay, so the hotter molecule, it goes upward, but whereas the colder one, being heavier than the hotter one, it comes down. Okay, so this is the process of convection. So that means in convection, it's the process of transfer of heat in which the heat is transferred by the movement of particle. Okay, not just from particle to particle, but after gaining a heat, the particle it themselves move from one position to the another position. Usually the hotter particles, it goes upward, and the colder one, it comes downward. Okay, so similarly in gas also, the transfer of heat occurs by the process of convection. So convection is the process of transfer of heat in which the heat is transferred by the actual movement of a particle. So some of the applications of convections of heat is, usually it is seen that the ventilations are provided at the top of the room, okay, not at the bottom. It's because in a room, okay, suppose if this is a wall, when the temperature of the room gets heated up, that means the air molecule also gets heated up. After getting heated up, we know that it rises upward. So the ventilations, they are at the top of the room, so that the heated air, the hot air, okay, when it goes upward, it moves out of the ventilations. Okay, and apart from this, the naturally occurring convection current, we can see it in case of a land bridge and a sea bridge, which you must have studied in geography as well. Okay, so what is a sea bridge? The sea bridge, it generally takes place in the daytime, when the cold air from the sea, it moves towards the land. Okay, so let's see. So during the daytime, okay, when the sun is shining bright, so what happens, there we have water. So this is a water and this one is a land. So usually during the daytime, which one will be hotter? The land is more hotter than the water. Okay, so the air above the land, it gets heated up. Okay, so it rises upward. Okay, now to fill up this empty space, the cold air from the sea, it moves towards the land. Okay, so and that is known as a sea breeze. The sea breeze occurs during daytime, and the sea breeze is the movement of the cold air from the water towards the land side. Now at night, what happens? The land cools much more faster than the water. So at night, suppose if this is a land and this is a water. Okay, so this is water and land. Now at night, the air above the water is hotter than the air of the land. So what happens? The air of the water, it rises upward. Now to fill up this empty space above the water, the cold air from the land, it moves towards the seaside, and that is known as a land breeze. Okay, so this is the natural application of convectional current. Okay, now finally comes the radiation. So the radiation is the process of transfer of heat without the presence of any medium. Okay, it does not require any medium to transfer the heat from one object to another by the process of radiation. So one of the example of radiation is, we obtain the heat energy from the sun. How is that possible? Because between the sun and the earth, there is a empty space. Okay, in spite of being that empty space, we receive a sufficient amount of heat energy from the sun. So that is by the process of radiation. Okay, so you must be familiar with these three processes of transfer of heat: conduction, convection and the radiation. And now finally we have the thermos flask. Okay, you have to learn how the loss of heat is minimized in a thermos flask. So the thermos flask, the construction is, it contains the double walled glass vessel. Okay, so innermost it contains a double walled glass vessel, so something like this kind. Okay, and which is silvered from inside also and from outside also, it is silvered. And between these two glass wall, it's empty space, that is a vacuum. Okay, and this glass vessel is kept inside a plastic cage. Okay, and then we have a stopper here at the top, which is usually made out of wood or cork. Okay, so now here if you pour a water, okay, that water remains hot for a very long period of time. How is that prevented? The first one, let's see, by conduction the heat does not loses here. It is because this glass is a poor conductor of heat. Okay, so the glass does not allow the heat to pass out. So hence by the process of conduction the heat cannot lose, because the glass and as well as this wood, it's a poor conductor of heat. Now by the process of convection, now since the process of convection it occurs through the gases, but here the space between the two glass vessels is empty. So thus we can say that the heat is not lost by the process of convection, because between the two vessels there is nothing, that is an empty space. And finally by the process of radiation, the heat lost by radiation is minimized by silvering the inner and the outer glass vessel with a silvered color. Okay, because the white color, usually the silvered color, they are a poor reflector of heat and as well as the absorber also. So hence by all the three processes the loss of heat is minimized in a thermos flask. So that is how the thermos flask can keep a hotter object hot for a longer period of time. So this all about the 6th chapter of your physics textbook. So once again go through your book and then I'll send you the solutions of the questions given in your exercise. Thank you.